Now our topic is true diff and apparenting. Okay. Before going to the main theme, main topic, true diff and apparenting, get a clear idea about the true thickness and apparent thickness. Suppose it's a road, it's a metal road, rather it's a national highway. Suppose so, it's a metal road, it's a national highway. Uh, so you have to, a student have to measure the width of the road. So what we will do, we will simply take a chain or take a linear scale and put the one end of the chain in here. Suppose this is X point. Put the another end, and select the point which is just opposite to the X. Suppose this is the Y, and put the tape in here, and we can get the linear distance. Okay, that linear distance, we can get the linear distance distance through the help of measuring tape, putting the tape in here and putting the another end of the tape in here, and we can easily get the linear distance. And this is the true thickness or the true width of the road. And what will be the apparent thickness or apparent width of the road? Suppose you put the one end of the tape in here and put another put and you put, but you can place the place, or you can select that point in that. This is the road, this is the one left hand side of the road. Suppose this is the right hand side of the road. You can place your measuring tape in here on the left hand side of the road, and you can put the tape in any point out of, except that point. You can put any point of the tape except the point of Y, which is just opposite to the X on the right hand side of the road. You can put your tape in here, you can put your tape in here, you can put tape in your here. Suppose you can put your tape in here. This is Amen. Here you can take the distance X and M. You can take the distance with the help of measuring tape, and you can get a linear distance. In same way, when the way the way student have collected the linear distance from X and Y, here X is just opposite to the Y, so only X is lies in left hand side of the road and Y point lies in the right hand side of the road, but just opposite to the each other. That means both are lies in straight line, both are lies in straight line, both are perpendicular to the each other in respect of this line. So then you can put X value, you can place your measuring tape in here, and you can put the another end of the measuring tape on the right hand side of the road, and you can take this linear distance. This is also the thickness or the width of the road, but this is not the true width of the road. That is the apparent. Okay, that depends on your choice, on surveyor choice, to how to measure the apparent thickness. They can measure from this point to this point, this point to this point. Okay, this is the apparent thickness. So what is the apparent thickness and what is the true thickness? Let's go for another example. Suppose it's a figure of a dancer. Suppose it's a dancer. Okay, it's a dancer. Okay, it's a dancer. Let's measure the length of her wrist. So also put a tape in here and select the exactly opposite point in the wrist zone of the dancer, that is Y, and measure this linear distance. This is the true thickness of the earth, or this linear distance is the true thickness of the wrist of the waist of the dancer. Okay, of the waist of the dancer. Okay, but if you put a measuring tape in here and select Y point in here, suppose this is Y dot point, and measuring this distance. This will be also be a linear distance, but this is not the true measurement value. This is not the true value of the width of the waist of the dancer. This is also the value. This is not the true value. Why this is not the true value? Because it is just opposite to the y. It is not just opposite to the, it's not just to opposite to the x value. Why it is not the true value? This value is the true diff, and this value is the, sorry, this value is the apparent thickness, and this value is the this value is the apparent thickness, and this value is the true thickness. What is the true thickness and apparent thickness? Let's go for the previous example. Suppose it's a highway. This is x, y point is just opposite to the x, and you draw a straight line, you draw a perpendicular straight line on the point of y. Suppose this is the perpendicular line, okay, on the point, vertical line on vertical line on y, and this is also a vertical line on x. Now measure the angular value in between the x, y and z, and that is 90 degree. X, y and m, that also be 90 degree. Then z, x and y also 90 degree, and it's also 90 degree. So what will be the true thickness? It's the minimum distance in between the two specific points. It's a perpendicular. It's the angular. It's a minimum distance between the x and y. So it is called true thickness. Okay. Out of the point of x, y, you can take any point in that side, right hand side of the road, and you can take any point in the left hand side of the road, and connect all these. Those are the thickness, but those are not the true thickness. Those are apparent. Those depend on the choice of the surveyor, choice of the individual. Okay, I think you can get clear idea through this lecture about true thickness and apparent thickness. So let's go for the true diff and apparent diff. So basic principle about the diff and the strike I have discussed in my previous class. Suppose those are the bedding plan. Those are the bedding plan. Suppose those are the bedding plan, and this is the horizontal plane. Suppose this is the horizontal plane. This square shape or rectangular shape base is the horizontal plane. Okay, this is the horizontal plane. So this is the bedding, inclination of bed, and the angle with the horizontal plane. This is horizontal plane. This is the inclination of bed. This is 90 degree. And you know what is the strike point? The beds are intersecting with the horizontal plane. Here the beds are intersecting with the horizontal plane, suppose, so on. So connecting this line, we can get the strike line. Okay, and this is the strike line. Okay, I think this idea is clear enough. Let's go for another geological map to get idea of apparent diff and true diff. It's a very simple geological map. Suppose this is a bedding plane. It's a bedding plane. Suppose it's the lower part of a bedding plane, lower part of a particular bed. It's the upper part of a particular bed. Last class I have told you how to draw a strike line. So connecting the value of contour, cutting the particular bed, you can easily identify the strike line. Suppose this is the strike line of 300 feet, and this is the strike line of 400 feet, because according to the scale of the map. So now the problem is how we will identify the true diff and apparent diff. Here one thing is very clear, that In geological map, we can plot, we can identify, we can measure all these things according to their section line. Section line depends on our choice. We can draw we can draw the section line according to our own need, own purposes. Here AB is a section line, and this is the line of strike line for 300 feet value. This is the strike line for 400 value. So identify dip. How we will identify the true dip? Okay, and how we will identify the apparent dip. So suppose here I am preparing a replica of that map, 300 feet, and this is the 400 feet. Both are the strike line. Okay, and this is the section line. This is A and B. For measuring the dip, to identify the dip, what is the basic rules? Here we can take this value, we can take this line here, and then with the help of compass, we can cut that value, and place it here. Okay, suppose this is the point of 300 feet, and suppose this is A and this is B, and this point is 400 feet. Suppose those are the elevation, those are the vertical interval, those are the height. Okay, we get those information from the value of contour cutting. So according to this map scale, 1000 feet is equal to 1 inch. So according to the map scale, if this line 400 and 300 feet never lies parallel to each other, so therefore according to scale we have to go for 1 unit higher than 300. Okay, this is the 400 value, this is the 300 value. With the help of scale, we can draw this line, and this angle is the dip. This is the true dip or apparent dip. I have told in last class that discuss in details that is the, suppose you are the person, your friend X is standing here and your friend Y is standing here, but so each and every point of that line, this is also 400 feet, this point is also 400 feet. Throughout the line, throughout the linear distance, height is uniformly distributed. This line is the line of 400 feet. So your friend X is standing above the 400 feet, and the Y is standing here. The height throughout this linear distance is 300 feet. Suppose M is standing here. The height, your friend M is standing here. The height of M is above the 300 feet. Suppose your friend Z is standing here. The height of Z is 400 feet. Okay. Throughout the linear distance, throughout the strike line, value is uniformly distributed. Height value is uniformly distributed. So what is the basic principle of slope? I have discussed in last class that the slope is the, suppose X is standing here, Y is standing here. Suppose this is X and you cut the value, Y is standing here. Suppose X is standing in 400 feet and X is standing above the 300 feet. Then the vertical interval is 400 minus 300, 100 feet. Then you plot according to scale the value of 100 feet. Then you take it. This is the horizontal equivalent. I have told in previous class. Then you can you can start walking to reach the Y. Then you have to go through this linear distance. This linear distance is the horizontal equivalent. So according to scale, you can get the value, because 1 inch is equal to 1000 feet. So you can measure this distance, okay, according to the linear scale, and you can get the dip. Suppose here if I want to plot it, For more convenient, we plot it in separately. If someone want to plot it in the geological map, he or she can plot. Then we can connect the distance. This is the minimum distance because those are the angle. This angle is 90 degree, this angle is 90 degree, this one is 90 degree, this one is 90 degree, and this value is 400 feet. Okay, this is 300 feet. So we can draw 1 unit. It lies above the 1 unit, above than the y. Then connect this point. So you can get the dip. That dip is true dip. Okay, because this one is 90 degree. This is the minimum distance. This is the width. This is the width minimum. This is the width, but perfect width, but true width. True width in between the strike line O and strike line P. This is the width, this is the horizontal equivalent. Okay, with the help of protractor, you can measure the dip. You can place, you can put zero in this horizon, this line, and you can measure this distance. This is the amount of the dip, and with the calculation you can also identify the dip, because you can place a scale here to the, you can put a scale here, and according to the map scale you can convert the linear distance in horizontal equivalent. Suppose this is horizontal equivalent is 600 feet, suppose, and you know the vertical interval is 100 feet. Then you can prepare tan inverse and you can get the value of true d through the drawing method. Even from that point you can also get, suppose you put the zero value here and you can identify this angle, you can identify that angle, the value will be same. That is the principle of true thickness and the true depth. Okay, and here we are saying only about the amount of the true depth. And now let's go for the what is the apparent depth. Suppose your friend is standing here, okay, and your another friend X is standing here. So M started walking and reached Y. So M or has to cover this linear distance. Okay, but this distance, linear distance, is M has to cover more linear distance than the X or Y, because it's not the perpendicular distance. Okay, so M started journey to reach X. Okay, suppose X and Y. Suppose X started journey to reach Y. Then X, that was the Y. That was the Y. Y. And Y, that was the Y. And the vertical interval between the XY is 100 feet. That dip, that amount was the true dip. Okay. Now X started walking to reach M. Okay, first thing, the horizontal equivalent was that amount. This is the horizontal equivalent for the cases of X and Y. And for the cases of X and M, X started walking to reach M, and X has to cover that linear distance second time. That's linear distance. This is the horizontal equivalent, but that amount of linear distance. But the height of X is 400 feet, so it's 400 feet. Height of M is 300 feet. Horizontal equivalent and vertical interval. Horizontal equivalent and vertical interval. So for the first cases, the vertical interval are the same for the both of the cases. Height is constant, but one X started journey to reach the Y to cover that amount of linear distance. Then X started journey to reach M or Z or P, maybe. And then X has to cover more distance than the point of Y. Then this is the horizontal equivalent. Then this is the height of X, and M lies in lies in 300 feet. Then you have to prepare this angle with the help of ground protector, and you can put the zero line here and you can measure the angle. Okay, let's clear what is the basic differences between the true dip and apparent dip. True dip, is the minimum distance between the two consecutive strike line. This is the consecutive strike line. Two are the consecutive type line. So, but true thickness is the horizontal equivalent in the cases of true dip is the minimum. Okay, and the in the cases of apparent dip, the always the linear distance between the two consecutive strike line, those are the two consecutive strike line, always be more than the minimum distance. Okay, suppose, so you get a clear idea for the first cases or second cases and third cases. All the dip, basically the vertical interval and horizontal equivalent. Vertical interval and horizontal equivalent. For the cases of true dip, horizontal equivalent is the minimum distance. Minimum distance. That is the perpendicular distance. This is the minimum distance in between two consecutive strike lines. And for the apparent dip, it's not the minimum distance. Here this line does not create always 90-degree angle. Okay, this is the apparent dip. Suppose get a clear picture about the true dip and apparent dip with the help of this true geological map. Suppose it's a geological map. Okay, so this is the section line A and B. With A and B, we can plot all these things here. Okay, for convenient, we are plotting it in here. Okay, this is the line A and B. A here, B is here. So this is another point, this is another point. Here the strike line intersecting with the section line. So with the help of compass, or divider, we can take this linear distance. Okay, we can take this linear distance. Okay, this is the point of 300. This is the point of 300 feet. This is the point of 400 feet. Suppose according to this scale, 1000 feet is equal to 1 inch. Suppose this is 0.1 inch. Then we can this angle with the help of protector, just put zero in here, put zero line in here, and you can, with the help of protector, you can measure the value of dip. This dip is apparent dip. Why it is called apparent dip? This is not, suppose it is M and N. This is not the minimum distance of two consecutive strike line. What will be the minimum distance? Either M will be the perfectly opposite direction, opposite point of M, or M will be perfectly opposite to the N. Then what will be the minimum distance? Then that will be the minimum distance. That will be the minimum distance. That will be the minimum distance. You can take it here, 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 throughout the two consecutive strike line. You can identify the minimum distance. Suppose this is O and P. P will be just opposite to the point of O. Okay, then take this distance, then take this linear distance. Okay, suppose all are same, and this is the point of 400. This is the point of 400. Here we putting the compass in the 400, and this is the point of, for the true dip, this is the point of 300. Then vertical interval is the same for the true dip and apparent dip. Okay, first time linear distance was along the section line. That was the apparent dip, horizontal equivalent for the apparent dip. And second type, vertical interval is fixed, but linear distance, horizontal equivalent, is the minimum distance or the in between two consecutive straight line. That is the this value. Then we can plot that angle. With the help of another color, you can plot it with another color, and I think it will be more convenient with the help of another color. So one is apparent dip, another is true dip. Okay, one is red color is true dip. Sorry. Black color is true dip and red one is apparent dip. Okay, suppose, so for the apparent dip and true dip, suppose if we draw all these things in here, what will be the result? Suppose this is the M and N, this is the horizontal distance along the section line. So we can plot all these things on that line. Suppose this is the line of 400, this is the line of 300. So take this in that way. This is A and B, this is A and B. Suppose this is the point of 300, this is the point of 400. So you can, with the help of red line, I am doing this, and this angle is the apparent dip. What will be the true dip? Draw a minimum distance line. Draw a minimum distance line. This is the minimum distance line because both are 90 degree. And this point is 300. This point is 400, taking 1 degree above. And this is true dip. Within the geological map, you can also identify the true dip and apparent dip. Okay. So I think you can get clear idea about the true dip and apparent dip. To concise my lecture, suppose this is strike line of 500 feet. This is 600 feet. Suppose this is section line X and Y. Then identify the true dip and apparent dip. So draw a straight line and take this linear distance through the compass. With the help of compass, put this linear distance. This is the point of 500 feet. This is the vertical height. This is the vertical height information of 600 feet. So this is not the minimum distance. This point is not just opposite to this point is not opposite to that point. Suppose this is O and P. Suppose it's O and P. Suppose it's O and P. Okay, taking this distance with the help of compass. Taking this distance from the help of compass, put O here, put P here, and this is the value of 500 feet. Through this linear distance, through the linear distance value is uniformly distributed. Through this linear distance value is uniformly distributed. So in each and every point of that line, all the height is 600 feet, and through the each and every point of that straight line, height value will be 500 feet. So, and this is 500 feet, this is 600 feet. So the vertical interval is 100, vertical interval is 100. And so with the help of scale, you can this angle, with the help of protractor, put 0 in here, put 0 in here. With the help of protractor, you can measure the angle. That is the apparent dip. This is the apparent dips. are the vertical interval along the section line, okay, or any choosing line, okay. And what is the true diff? Okay, just identify the point just opposite to O, or just opposite to P, or just opposite to, or select any point lies opposite to each other. Suppose this is the Z, and what will be the result? Then from the P point, identify the, you can draw it separately as apparent and true, okay. And you can identify, you can measure the horizontal equivalent. This is P point. Put your compass in P and identify the distance, okay. This is the Z. Z is the minimum distance. But here in the cases of true deep, horizontal equivalent is that one, we place it in here, and vertical interval is 100. We know that. Then we can we can we can join the point, and this angle, this is the higher. True deep always higher or equal in apparent. Apparent also, or apparent is also less, also shows less value, lesser value than the true deep, or equal, or shows the equal. If strike line, section line lies perpendicular, cut the section line, cut the strike line perpendicular, then apparent and true deep value will be same. Otherwise apparent diff always less than the true diff, okay. That amount of diff is true diff, and this amount of diff is apparent diff. So both are the same. True diff and apparent diff method is same. It's nothing but the principle of horizontal equivalent and vertical interval. For apparent diff and true diff, vertical interval is the same, but for the cases of apparent diff, horizontal equivalent along the section line, its horizontal equivalent for the true diff is minimum distance between the two strike line, but two consecutive strike line. Minimum linear distance distance in between two consecutive strike line. This is the basic differences between the true diff and apparent diff, okay. I think you can get a clear idea with the help of with the help of this lecture. You can easily draw and interpret geological map. Suppose this is a geological map. XY is a section line. This is the strike line of the value. The value of the strike line is 200, and value of this strike line is 300. Dip direction is 300 to 400. If you pour water, it goes to higher value to lower value. So what will be the apparent dip and true dip? So suppose I try to plot all these things along the section line, okay. This is the value of 300 feet. This is the value of 200 feet. So this is 300 feet. So according to scale, you can just this angle is the apparent dip. What is the true dip? Just identify the point just opposite to any point. Just opposite to any point lies in the strike line of the 200 value and the 300 value. This is the minimum distance between the two consecutive strike line. This is the 200, this is 300. Suppose according to scale, and here in the both of the cases, this is first one, black one is the true dip and red one is the black one is the apparent dip and red one is the true dip. Both the cases, the vertical interval is same, but horizontal interval for the apparent dip along the section line, and for the true dip, it's the minimum distance in between two consecutive strike line. I think you can draw apparent dip and true dip. And another thing I want to say that it's first class I have told you that diff is a vector quality. I have told in first class that diff is a vector quality. Vector quality. I have told in first lecture. What do you mean by vector quality? It measures two things, direction and magnitude. Okay, but amount. Okay, it measures two things, direction and amount. Amount and direction. Now we can get the idea how to measure the amount of true dip and amount of apparent dip. Second question, how you will measure the dip direction? This is not very important for the student, but without direction, it's very incomplete thinking and incomplete work. So get an idea about the direction. Suppose this is the section line, it's A and B. Suppose this one is strike line, this one is strike line. This is the strike line value is 500 feet and 600 feet. Okay, so we have to identify the true dip. First one is apparent dip. Suppose this is point P, this is point Q. So apparent dip, this value is the 600 feet, this value is 500 feet. This is the horizontal equivalent along the section line for the apparent dip. So for the apparent dip, if this point is 500, so we have to identify vertical interval. The differences between vertical interval differences between 500 feet to 600 feet is 100 feet. So P point lies above the 100 feet. So what will be the apparent dip? And this angle, this amount of dip is apparent dip. Okay. And what will be the true dip? Just identify a point just opposite to the Q. Lies in the consecutive straight line. Suppose this is X. The value of X is 600 feet. Value of Q is 500 feet. So vertical interval is same in the both of the cases, as well as vertical true dip and apparent dip. So you have to go for 100 feet and you can draw that line. That amount of dip is true dip and apparent dip. Okay, so I think you can get a clear idea about the true dip and apparent dip. At the starting I told you, suppose this is a road of right hand side, this is the road side of left hand side. Suppose Q is standing here. What is the width of the road? Just you can identify the linear distance just lies opposite to the Q. So X. Okay. Suppose right hand side height of the right hand side of that point of the road is 500 feet, and the opposite side of the road the height of the X point is 600 feet. So you start walking to go reach X, and then your height will be increased 100 feet, and that is the true dip. And what is the apparent dip? If you're standing in the right hand side of the road and if you reached here, this is not the minimum distance. Why it is not minimum distance? That it does not perfectly lies in the opposite direction of Q. So and reached here, but height information will increase 100 feet, but this is the horizontal equivalent. This is the apparent thickness, and this thickness is apparent thickness. This dip is apparent dip. This thickness is apparent true thickness. This dip is true dip. Okay, this is the amount of dip. Now come to the point of direction. Okay, I would like to mention one thing. In last semester, I think there was a chapter that whole circle bearing and reduced bearing. Here the principle of reduced bearing will be used. What is the principle of reduced bearing? Suppose this is north, south, east and west. Quadrant 1, quadrant 2, quadrant 1, it's moved clockwise in reduced bearing. Okay, it's quadrant 2, quadrant 3 and quadrant 4. It's 0 degree to 90 degree. it's moved clockwise and anti-clockwise both. In clockwise, north to northeast, first zone known as north to northeast, it starts from 0, that is north, and moves up to east, that is 90 degree. And it also moves in anti-clockwise, north to northwest, that is the zone 4, north is 0 and west is 90 degree. And then come to the south. Here always we measure the direction in reference to north to south. It's also moves start from 0, put 0 degree in south, and it moves up to 90 degrees south to east. And this zone also moves clockwise, it's south to west. Suppose this is the basic principle. I have uploaded a video for the general student of 4th semester. You can take the help of that too. Okay, now come to the direction. We are using that principle. Suppose in map, this is north, this is south, this is east, this is west. It's fixed. And now come to the true deep. This arrow point is the true deep. True deep lies in the zone of north to west. North to west. So north to west. And you put a protector, you put 0 in the north, moves anti-clockwise and measure this direction and put the value. Suppose it is 52 degree. So the direction of the true dip is previous one was the amount of dip. Now the direction of dip. Now direction of the dip is north to 52 degree west. Okay, because it lies in that zone. Suppose some dip lies in that zone. How you will measure? Then you will measure in reference to, actually you have to measure in reference to that way, north reference in south reference. Okay, and you put a protector in here and place 0 in here and move that way, that is south to east, and measure this direction. In that direction it is anti-clockwise. Okay, suppose this is 45 degree, then the direction will be south 45 degree east. This is the method to measure the direction of the dip. Dip accompanied by the two things. First is amount of dip and the direction of dip. For the measuring the direction of the dip, we have to follow the principle of reduced bearing. Reduced bearing. Okay. I think you can get an idea about true dip, apparent dip, and true thickness, apparent thickness, all these things, and try to practice all these things according to your own way. And another thing I want to say that, okay, sometimes you can plot all these things, all the geological map in inch graph paper, because here the scale is 1 inch is equal to 1000 feet. And to plot, if you interested, you can plot in tracing paper, you can plot in plain paper, but more convenient way to plot all these things in inch graph paper, because all this scale is in the inch. Then you can easily plot, you can easily identify the thickness of the bed. You can very easily measure precisely the value and the angle of the dip angle, all these things, because it's marked with the map scale. And sometimes student prepared first time student prepared the landform and select a vertical scale. But if you change the vertical scale according to your own way, then you have to change the all scale. Here student are taking 2 inch is equal to 2 inch is equal to, or 1 inch is equal to 200 feet. 2000 feet or the 5500 feet. Suppose students are changing the scale. If you want to change the scale, you have to change all these scales, even the deep, all these things, height information, vertical interval. So it's not very good and convenient for the student, and it will provide erroneous result. So better follow this map scale. 1 inch is equal to 1000 feet, and if you try to do or plot all these things in graph inch graph paper, then it will provide more convenient, more precise, and more accurate result. Thank you very much.